Hi, who is that?
Hey.
Ah, Celine, it's you. How are you, Celine? Yes, I'm good. Thank you, teacher. Very, very good. How are you, Mr. Carson? I'm good. Thank you, Celine. Okay.
Hi,
Hi, Ilknur. How are you?
I'm good.
Uh, Ilknur, do you remember what did we do in the last class? During the last class, I just forgot. We practiced some questions. I answered your
Yes,
questions, right? And
yes.
did we finish this
No,
2015?
we
2000?
didn't. I think we didn't finish.
Okay. 18, 19, 20, 21. Oh, I see. With this 2015, how come we didn't finish it? Okay, let's finish it then. Okay. I think I should not open this. Okay. Adilhan, are you still here?
Yes.
How are you, Adilhan? Is everything okay?
Okay.
Good. Here we have Adilhan, Salin, Ilknur, and Ibrahim, and Rauf. Maybe he will join soon, and Tariel also soon. So guys, very good. Good to see your names on the screen once again. Also hear your voice. Okay. Today is, I think, what is it? It is March 18th. So we are going to finish this paper today and start new paper. So as you know, we are getting close to the Sasmo date. That's what we are preparing for. And we have only around 1 month left. Okay. So now, if you have time, you need to review these questions. If possible, you need to resolve these questions once again, and you will see how much you can remember, how much you have learned, okay? Still, if you're struggling with the questions, that means that you need to practice more. But if you think that, Mr. Qasim, I'm enjoying my life and everything's okay, that's also fine. We will see, okay? So, Ilknur, did we solve this question? Do you remember?
No, we didn't.
Then I think we stopped here then. Okay, let's continue from
Yes.
here. Today is March 18. Ilknur, let's start with you. Can you read the question?
Yes, Daniel wants to cut rectangular cuts of length 3 centimeters by 2 centimeters from a rectangular sheet 15 centimeters by 19 centimeters. Find the biggest number of cuts that can be cut from the sheet.
Okay, can you answer this question without thinking or writing anything on a piece of paper? What do you think? What is the answer here?
Um, I can't say it without writing the solution on a paper.
Okay, write it then. I give you 1 minute, everybody. 1 minute. That's a very easy question. Ibrahim, when will you participate in the class? Ibrahim,
Yes, Mr. Chosen.
when will you participate
Hello,
in this
teacher.
class?
When?
Next year?
I think 6 year. No, 6 months. I think.
After 6 months?
Yeah.
No, I'm asking you, Ibrahim, you never participate in this class. When will you be active students in this class?
Always. I want.
Huh?
I want active always.
But you never solve any question here, Ibrahim. I never get any answer from you. Celine, why 158? How is that possible?
It's possible.
Huh?
It's possible.
How?
I mean, I multiplied
Is the
19.
answer C?
Eh,
The answer is not C.
Why?
that's
How is it
C.
possible? How can you cut 158? Can you tell me how did you get that answer?
19 by 50 and
I
divide
found
by
the area of both
Okay.
rectangulars.
Eh,
Then I divided their areas.
Hmm. Yeah, actually, Ilknur, here the question is, what is it? Daniel wants to cut rectangular cars, okay? Rectangular cars of length 3 centimeters by 2 centimeters. It must have these dimensions, okay? From a rectangular sheet 50 centimeters by 19 centimeters, okay? So now if I ask you one question, Celine or Ilknur, let me ask you one question. For example, if I have this kind of strip of paper, okay, and let's say width, it is 1.5 centimeters. And the length, let's say it is 40 centimeters. If I ask you, Ilknur, how many such rectangle cars of 3 centimeters by 2 centimeters you can cut from this paper? How many?
I will still do the same.
Tell me the answer, how many?
10.
10?
Yes.
Ignore, how can you cut here? As you see here, the width is
One.
1.5, but
One.
here I need 3 by 2 carton papers, right? It should be 3 by 2. How can you
Is
cut
the
from
answer
this?
one?
Huh?
I can't. One. Is the answer one?
No, it is 0. You cannot cut any carton, I mean, any rectangular card from this piece of paper because as you see here, the width is 1.5 centimeters. How can you cut from this?
You
Yes.
can just do the lens bigger and that's it.
Yeah, of course. How can it come from here? If you just cut from here, as you see, the width is 1.5 centimeters. You cannot cut any rectangular card from this piece of paper, even it is long enough. And what is the area here? 40 times 1.5, that's equal to 60 centimeters squared. And this one is 3 times 2, 6 centimeters squared. We're saying that 6, right? It's not possible to get any rectangular paper from this. Why? Because it is too thin, right? It is 1.5 centimeters in width. So that means it's not possible. That's why, because you should understand that point. It's about liquid, for example. Okay, at the time your approach is correct because the water, it can take any shape, right? But here it's not that way. So here to be, we actually here the idea is we need to cut out this rectangular cars of length 3 centimeters by 2 centimeters from this rectangular sheet in such a way that with minimum waste of paper. How can, anyway, we will waste some amount of paper, but what will be the minimum waste? At the time, actually, I will just choose this length, okay, and cutting the papers where the length is 2 centimeters, 2 centimeters, 2 centimeters. Why? Because 50 is divisible by 2. That's why. Okay. If I choose 2 from here, how many paper I can cut? Here I can cut 25. And how about width here? If you do a 19 by 3, how many 3's do we have here? 6. So it is 6 times 25, 6 times 25. So maximum I can cut 120, 150 rectangle cards from here. Hello.
Yes.
Any question?
No.
Did you understand the point?
Yes, I
Yes.
did.
Very good. So the answer is 150. It says the biggest number, also 144 is possible. At that time, we will waste more paper. Okay, but here the biggest, that is 150. Now, if they ask how, this in length, I will just cut into 25 equal pieces and with 6 equal pieces. That's it. And this one will be just waste. Some part will be wasted. Anyway, that answer is 150. Okay, we will move to the next question. How come we skip that question 14? Celine, read the question.
Jerry drives 2,000 kilometers during a trip. He rotates the tires, 4 tires on the car and one spare tire, so that each tire has been used for the same distance at the end of the trip. How many kilometers are covered by each tire? What is tire?
İlknur, what is tire?
Um, I think it is in the wheel of a car.
Yeah, what is it in Azerbaijan language or Russian?
Колесо.
I don't know
Balisto.
in Russian, but I think I know in Azerbaijan. I'm not sure.
What is it? Tell me.
Tormuz. I don't
What?
know.
What?
Tormuz.
Tormuz?
Yes, I
What is
don't
it?
know. The car stops once you hit that thing with your feet.
No,
It's not like that. Yeah, tire is just, the wheel. Every like bicycle or motorbike and cars, they have 4 wheels, right? For example,
Yes,
let's say this one is Selin's car and the one tire and the wheels actually, but the wheel is covered by tire here. Or simple, it's just a wheel. You can tell me here. All right, very good. Who is drawing this? Huh?
me.
Oh, Selin, you know this. That's correct. This one is tire, right? Because usually if you are traveling, for example, a long distance, right? Actually, your tire may go flat, right? It may actually, what is it? The air may go out because of some, we call this, what is it? Fracture or something. Anyway, that's why we always carry one spare tire. All right. Maybe I think next time I need to put a picture of tire. Okay, so now a car, it has 4 tires. All right, number 1, number 2, number 3, number 4. And also at the back, we just keep one spare tire. And now it says that he rotates the tires. Why? So that actually none of them actually, or all the tires will be used for the same amount of time or for the same amount of distance, let's say. 4 tires on the car and one spare tire, so that each tire has been used for the same distance at the end of the trip. And what is our trip? It is from, what is this, starting from A to B, and that is 2,000 kilometers. Okay. The question is, how many kilometers are covered by each tire? Guys, think. You have 2 minutes, okay? And after that, we will see. Let's see who answers how.
so there are 5 tires in total.
Yes, that's right.
Is the answer 40?
40?
Yes.
How is it possible, Ilknur? Here the distance is
Not 40,
2,000 kilometers.
400. 400, 400.
No, you are getting close, but Ilknur here is saying that how many kilometers are covered by each tire in total?
Mr. Kazim, is my answer correct? I wrote in chat.
No, Selin, that's not correct.
Oh,
Raul, do you have any idea? Why gentlemen are so
no.
quiet, you know?
I
Adilhan,
can think very quickly.
you cannot think quickly. Why?
I don't know because
You mean you cannot think?
I
Huh?
was listen before this lesson, and I'm so tired.
Oh my gosh. Okay, if you're tired, what can we do, Raul? Just cross your legs, lie down, okay? And put your hands behind your head and just watch and drink some coffee or whatever you like, okay? Try to enjoy your time, okay? If you're tired, we have nothing to do. Now, we have technology that's so interesting. And I'm just watching my kids, they're just lying down and walking from one side to another side. And I said, okay, my daughter, what are you doing? I said, oh, daddy, I'm in the class. That's so funny. Anyway, what can we do? Now, the important thing is just to get some idea and learn and to think about your future. Anyway, Selin, are you ready?
Yes.
Very good. Now we'll just do very simple, what is it? Brainstorming. Okay, but it is not very difficult question, but it is tricky question. Okay, so that is
Please,
our distance. Okay, so
please.
now I start traveling with my tires. Let me just number them, okay? That is the first tire, number 1, number 2, number 3, number 4, number 5, right? Now I am ready for the trip, so we just start our journey from here. Now in the first part, I'm just using number 1, number 2, number 3, and number 4, okay? I just travel some distance, all right? And after that, I change this. But now our spare tire is 5. So I will change with one of them, right? So I just rotate this. I will start with 1, okay? So now after that, I just change with 1. I replace 1 with 5. So now I have 5 here. Other tires are the same, 2, 3, and 4. Now my spare tire is 1. It's not being used. And we travel a little bit here. Again, I will change. Now I change 1 with 2, right? Because 5 already changed. Now here we have 5 and 1, 3, and 4. But now here I have 2, right? Again, I travel a little bit, okay, the same distance. Now I change 2 with 3. So here we have 5, 1, 2, 4. And which one is in a spare part? Now, that one is 3, right? And we travel a little bit again. Now I change 3 with 4. So here we have 1, 4, 5, 1, 2, 3, and 4 is spare part. As you see here, how after changing this, right, the last change actually, I can reach my destination. Now we have already arrived at our destination, so we don't have to change the tires anymore. Now, Selin, if you look at this, for example, tire 1, how many times is it used? Tire 1, as you see here, 1 time here, and 2 times, right? And 3 times and 4 times. For example, tire 2, right? Tire 2, 1 time, 2 times, right? And here 3 times and 4 times. If you look at this, every tire is used 4 times. Now, actually, how many times actually we just divided this distance here. It is 2,000 kilometers. We have 5 intervals, right? 2,000 is divided by 5. That is equal to 400. So with each tire, we have traveled how many actually jumps here? 4, right? So that is 4 times 400, right? That's equal to 1,600 kilometers. That means that by each tire or each tire travel for 1,600 kilometers. Celine, did you get the points?
Yes.
İlknur, how about you?
Yes, I also did.
Very good, very good. That is so beautiful question, and it's not a new question. Actually, I saw this question, or I solved this question maybe like 25 years ago, I think, when I was like at high school. I think I remember when I was preparing for math Olympiads. So at the now still they put this question here. That's also interesting. That means that it's very logical and nice question. Not everybody can solve this question. As you see, at the first try, it's a bit tricky question. But when you understand this question, now it makes sense, right? As you see here, each tire is used for the same amount of distance, which means that every tire is damaged or used for the same amount, right? That makes sense. Okay, now let's continue. Adil Han, are you here?
Yes,
Adil Han, can you read the question?
yes. Jane is at a road junction is four possible roads to her friend's house, but she did not know which road to take, so she asked some passerby for directions. First passerby, your friend's house is not on road one. Second passerby, I did not want to live near your friend, so I moved from road two to road four. Third passerby, I have taken road two to the beach before, but I have not passed by any house. Fourth passerby, your friend stays on road three. If only one passerby is telling the truth, on which road does Jane's
Okay.
friend live?
The question is here. It says that if only, right, one passerby or one of the passerby is telling the truth, what does it mean? It means that the others are lying, right? The others are telling a lie. So in which road does Jane's friend live? Guys, let me give you 2 minutes. Think a little bit. That's a logic puzzle, okay? And if I ask me, Mr. Carson, what method would you suggest before you start? I suggest you to make a table, okay? To make a table means we are talking about 4 people, right? And after that, their answers, all right? And if their implications, let's say, let's just use tick, all right? For example, your friend's house is not on road one. What does he mean? He means that his friend's house is maybe in road two or road three or road four, right? It is not in road one. That's what he's trying to say here. Okay, guys, just try. Okay, let's discuss this after 2 minutes.
I found the answer.
What is the answer?
Don't say, please, I'm sorry.
Okay, okay. Nikki, can you write to the chat box? Let me see. Are you typing your answer?
Yes, I am. It is still sending.
Okay. No, Celine, the question is on which road does Jane's friend live, right? Which road? Road 1 or 2 or 3 or 4?
I think on road 3. Okay, let it be road 3.
Road 3. Ignor's answer is road 2. And gentlemen, they are tired, I think. Adilhan, Raul, and maybe they are sleeping. I don't know, maybe playing games or they're just watching something. All right.
I think road 1.
Really, Adilhan? That answer is
Yeah.
correct. How did you find that?
Like the second passerby say he didn't want to live near her friend, and he moved from road 2 to road 4. And like fourth passerby says it's on road 3, and how can the second passerby live near him if he is on road 4 or road 2?
Okay,
Like that.
good. Let's do like this. First, let's try to understand the question. I think until the last statement, you understood everything. But let's say we're telling in the last sentence, it says that if only one of the passerby is telling the truth. And yeah, once again, it means that only one person is telling the truth and others are lying, right? On which road does Jane's friend live? So if I just make a table here, let's start with the first one. The first passerby says that your friend's house is not on road 1. He's implying that, okay, here, if he lives in road 1, that means that he will be lying, okay? So that's why, let me just put cross here for the liars. If he's living in road 2 or road 3 and road 4, that means that he is telling the truth. So here, if he's living here, that means that person 1, passerby, is telling the truth. Second one, I did not want to live near your friend, so I moved from road 2 to road 4. And what is he implying here? He's saying that your friend is living or was living in road 2, but I didn't want to live in the same road with your friend. That's why I moved to road 4, right? So that means that he's implying that your friend lives in road 2, not in road 1, not in road 3, not in road 4. Third passerby, I have taken road 2 to the beach before, but I have not passed by any house, right? What does he? It means that if there is no house in road 2, that means that nobody is living there, and also particularly your friend is not living there. So that means that here his house is not in road 2, right? And the third passerby's answer, not in road 2. Maybe it is road 1, road 3, or road 4. And the last one is saying that your friend stays on road 3, right? It means not in road 1, not in road 2, and not in road 4. Ilknur, can you tell me, if you look at the columns here, in which column only one person is telling the truth?
First one, passerby.
The first one, right? If you look at the one,
Yes.
right? If he's living in one, right? Actually, he's telling the truth, and others actually are lying. In the second one, 2 people are telling the truth, 2 people are lying. In the third one, again, 2 people are telling the truth, 3 people are telling the truth, one person is lying. In the last one, 2 people are telling the truth, 2 people are lying. But in the quote, it says that only one person is telling the truth. That means that actually the answer is, right? Actually, that what is it? Jane's friend is living in road 1. Instead of this telling the truth, if I just write telling a lie, for example, the answer would be road 3, right? As see here in column 3, one person is lying and others are telling the truth. If we say that if only one person is telling a lie, at the time he would be living in road 3. But here, telling the truth, only one person, so his house must be in road 1. Okay, Salin, is your answer correct?
No.
Ilknur wrote 2. And but Salin, did you understand how we solve this problem?
Yes, I did.
Very good. If you understood, that's great. Let's move to the next question. Raul, are you here?
Yes.
Do you have energy to read the question?
I don't think.
Do you have energy to read the question?
No.
Okay, Raul, I will read for you. As you see in the picture, in the diagram, we are given a rectangle and it's divided into smaller 3 rectangles, and also we have 1 square, right? Actually, the bottom part is, this one is square. All sides are equal. If the perimeter of the unshaded rectangle, let me say we are talking about this rectangle, right? So if the perimeter of the unshaded rectangle is 48 centimeters and the area of the square is 36 square centimeters, find the total area of the shaded rectangles. That means that if this area is A, this area is B, the question is, what is A plus B? Okay. Guys, you have 2 minutes, give a try, and after that, we will see this together. Yes, Ilknur, that's a correct answer. Salin, how about you?
Can you give 1 more minute, please?
1 more minute. I'll give you 1 more minute. Exactly. Time starts now. Adilhan, do you have any answer?
No, but I'm trying to do it.
Did you write the perimeter of the rectangle?
Yes, but I don't know like the length and the width of the rectangle.
So you don't have to know, but do you know their length?
No,
I
I
mean,
know only
not the line.
I only know the side of square.
Okay. Salim?
I have the answer. I got 1060. I mean 1060.
1060?
Yes, I chose big number.
1060. Are you sure?
Yes, I just chose another number. I mean, for the little, I mean, not little, but the rectangle that is unshaded, I've taken 10 and 14 because 10 plus 14 is, oh my God, what am I talking about?
Yes, Salim, actually, did you label, for example, this unshaded rectangle? This is its length, and this one is width, right? And the question is said the perimeter is 48. What is the perimeter? How do you find it? It's 2 times length plus width, right? That's equal to 48. Now, if you divide both sides by 2, here we have length plus width is equal to 24. We don't have to know actually their individual value. But here, what is
But
A? Huh?
14 and 10.
Yeah, we don't have to know that actually. We don't have to know. So here, since actually the area of the square is 36, that means that this side should be 6, this side should be 6. That means that how about this one? Opposite side of the top, right? So this should be W, and this should be 6. And how about this one? Length, it is L, and opposite side, this one is 6. And what is area? A plus B, right? So what is capital A? That is 6 times L. So that is 6L plus how about B? Length times width, 6 times W. So 6 times W. And 6 is a common factor. Here we have L plus W. And we know the sum of these two things, right? L plus W. What is it? 24. So here I can just use the value 24 because I don't know what is L. I don't even need it here. So 6 times 24, that's equal to 144 cm squared. Okay, Salin.
Yes.
Adilhan, did you get it?
Yes.
Good. Adilhan, can you read the question?
What are the dimensions of a cuboid that is made from 2015 1 centimeter cubes if all the sides of the cuboid are longer than 1 centimeter?
Very easy question, guys. First, give a try. Okay, you have 2 minutes to have an idea. Then we will do this. Very easy question, Talent. Come on. Include any answer?
No.
Did you understand the question?
Yes, I did, but I didn't understand how to do it. Why
You
does
did
it
draw a
say if?
cuboid.
Yes, I did. What
Okay.
does it mean if? I mean, how am I going to solve it if it says the sides are longer than 1 centimeter?
Okay. It says the dimension of the cuboid is made from 2015 1 centimeter cubes. Number one. So what do you think about the length, width, and height, are they whole numbers or also they can be fractions? Ilknur, what do you think?
Still solving.
I
Is
mean,
the answer 2015?
no. It says the dimensions. It has how many dimensions does it have? Huh? How many dimensions does it have, Ilknur? Three, right? Length,
Yes, 3.
width, and height.
Height.
So the question is, what is length? What is width? And what is height? Right? So Celine, do you agree with me that I'm saying that all these dimensions, length and width and height, they are whole numbers? If you agree, why? If you don't agree, why?
Uh, I don't agree because it can be any number.
But here it said in the question, Celine, we are actually building this cuboid or making this cuboid using 1 centimeter cubes, right?
Mm-hmm.
So that means that actually here, how many? You are just putting some of them here and some of them here and some of them to the height, right? So that means the length, it cannot be a fraction. It must be a whole number because here we are just using small cuboids. I mean, cubes. Okay, so that means that we are just using bricks. Okay, here it doesn't say that we can use half or some smaller part of this brick. No, not like that. We are just using these cubes and building this anyway. So which means that now from here, the volume is length times width times height, right? And how many cubes we use here? 2015, and the dimension is 1, right? It is like 1 1 and 1 1, right? And what is the volume of this? It is just 1 centimeter cube. And how many do we have? It is 2015. So that means that the volume of this cuboid is 2015 centimeters cube. So that question is actually, can I just find 3 numbers, whole numbers, whose product is 2015? To do this one, I need to find prime factorization of these numbers. Just a minute. It's not charging. Just a minute. Let me check my battery. I don't know why it's not charging. Oh my gosh. Okay, Ilknur, do you understand what I'm talking about?
Yes, I did.
Good. Then 2015, as you see here, the last digit is 5, the first observation. That means that it is divisible by 5. So I can write it as 5 times 403. And how about 403? Is it divisible by 3? No. 5, okay, no. 7, no. 11, yes, right, 35. It is 53. No. 13, yes, right? If you divide by 13, right, 403 is divided by 13, it is 339. If we have 1, 13, 31. Good. So it is divisible by 13. So I can write it as 13 times 31. So what are the dimensions? Usually the length in the longest side, right? So the length is 31 centimeters. And width, this is 13 centimeters. And how about the height? Height is 5 centimeters. The dimensions must be these numbers. It cannot be different numbers. And because Selen here is saying that we are using 1 centimeter cubes, right? We are not actually breaking them into pieces and using them. It's not like that. Just using this like building blocks, we are making this cuboid. That's why actually all the dimensions must be whole numbers. Okay, that's it. Let's move on. Okay, we have 4 more questions. Let's try to finish this. Ilknur, can you read this quickly?
Should I read it?
Yes, can you read it?
A number gives a remainder of 3 when divided by 10. Another number gives a remainder of 4 when divided by 10. The sum of these two numbers is multiplied by 6 to give the third number. What is the remainder when the third number is divided by 10?
Okay, that is very easy question. Selen, if I ask you, just can you tell me one number? When you divide by 10, the remainder is 3. What number is it?
Can I
Uh,
say it? 13.
13, right?
13.
And it says that another number gives a remainder of 4 when divided by 10. What is
14.
that number?
14.
It is 14. Even actually, I can choose 3 and 4. But for you to understand this, I can choose 3 and 4. It says that the sum of these two numbers is multiplied by 6. So the sum of these two numbers, that is 27. And after that, we multiply their sum by 6. That's equal to 120, 42, 162. The question is, the sum of these two numbers is multiplied by 6 to give the third number. What is the remainder when this third number is divided by 10? So if you divide this by 10, that is 16 times 10 plus 2. So this one is the remainder, right? So if you divide the result by 10, the remainder is 2. Just in this simple way, you can solve this problem. And the next question, it is a little bit hard question. Okay, let's also do this together because we are running out of time. And 25, maybe one question is left. And after that, we will see. Find the 2015th term, okay, of the following sequence. And how we are forming the sequence, as you see here, 1 is written once, 2 is written twice, 3 is written thrice, 4 is written 4 times. And in this pattern, actually, we just continue writing other terms of this sequence, number sequence, right? If you just continue this, what number will be in the 2015th term? Now here, actually, the first term is, what is it? 1. The second term, 2. Third term, 2. Fourth term, it is 3. Fifth term, 3. Sixth term, and seventh term, blah, blah, blah. It continues, right? And as I see here, for example, 1 is used once, 2 is used twice, and 3 is used 3 times, right? So now suppose that after certain actual point, let's say here we are writing n, n, n, n. How many n's do we have here? We have n n's, right? 1, 1, 2, 2 twos, 3 threes, 4 fours, and here it is n n's. Now, if I just find how many numbers do we have here, right? How do you find this? Now, to find this sum, right? 1, I have only 1. 2, I have 2. 3, 3, dot, dot, until n, right? So what is this here? We have just the sum of the first n natural numbers. So that's just equal to, if you remember, that's equal to n times n plus 1 over 2, right? So suppose that it is, can we just actually find the product of two consecutive numbers and their sum is 2, that's equal to 2015. Is it possible or not? Actually, suppose that that's equal to 2015, okay? Suppose, because here, suppose that here, when we just stop here, and after that here we have 2015 terms. Does it work or not? I don't know, okay? Let's see. Now from here, that n times n plus 1, it should be equal to 2 times 2015, which is equal to 4030, right? And here, these two numbers, they're close to each other, right? How can I find this number? I just approximate. For example, n should be approximately equal to square root of, what is it, 4030, which is approximately equal to 63 point something. But I'm just guessing here again. Actually, Selen is really good at making guess. You can just make a guess and find this number. If n is equal to 63, for example, what happens here? 63 times 64, which is equal to, all right, just a minute, 63 times 64, that's equal to 4032, 4032, which means that 63 times 64 over 2, if you divide both sides by 2, it is 2016, right? So that means that instead of n, I can write this number that here we have, for example, if I write 1 and 2, 2 and 3 and 3 and 3 dot dot continue. If I write here 63, 63 dot dot and 63, I wrote 63, 63 times, right? Now, how many numbers, how many terms do we have altogether? If you count this, as you see here, how many terms we have? 2016. Why? Because 63 times 64 over 2, that is the number of numbers here, that's equal to 2016. So which means that here the last 63 is 2016's term. And also the previous one will be 63. So that means that the 2015th term of this sequence is, what is it? 63. Selin, did you get anything?
Something.
Yeah, that's a little bit harder question. It's not so hard if you understand the idea, but you need to think. Okay, without this, also you can guess. All right, like for example, 2015, right? As you see here, we are just actually counting the number of digits, right? The numbers. Each number is written. Um, uh, what is it? As the quantity of that number. If it is two, two times. If it is three, three times, and you can get the answer. But actually, I suggested to practice to solve this question again yourself to understand better. Anyway, guys, and we have two more questions, but let me finish this here, because if I just solve this, it takes more than 5 minutes, and we don't have that much time. We have two questions here, 24 and 25. Find the remainder when 3 to the power of 2015 is divided by 4. And the previous one, again, that's a little bit not easy question, not very hard question. You should give a try. And how about this question? This question, again, let me just give you one idea. We know that 3 squared, right? If you divide 3 squared by 4, the remainder will be 1. Okay, so you need to use this idea. So since it is 1, now, because for example, what does it mean? It means that if you divide actually 2 to the power of, I mean, if the power of 3 is odd number, and if you divide this by 4, the remainder is always 1, right? Because of this one. Okay, and if I ask me the reason, maybe next time I can explain in details. So what you have to do here is this 3 to the power of 2015. I can write it as 3 to the power of 2014 times 3, right? It's just how we actually write as a product of two numbers. Anyway, so this 2014, I can write it as 3 squared to the power of 1007 times 3. But if you divide this number by 4, the remainder is 1. 1 to the power of anything, it is 1. And if you multiply this by 3, so the remainder will be 3. So if you divide 3 to the power of 2015 by 4, the remainder is 3. Thank you very much. That much is enough. Only one question is left. That is your homework. Okay, you should try. And if you solve this nicely, please take a picture. Okay, send it to me to my WhatsApp. Let me see. Okay, your details. I would really appreciate if you could solve this question. Okay, you can take a screenshot, or I think I have already shared this paper with you. Okay, thank you very much. Have a nice weekend. I will see you next Monday.
Bye.
Bye bye.